So let's start today's class. That is the computer organization module 4 lecture 5. Now we know that input and output device is one of the important device in computer system. We already know that there are the different types of input and output devices. Input device means be keyboard or scanner, and output device means there may be monitor, printer, etc. So input and output device is one of the main component of a computer. Now when CPU has to take the data from the memory, the data should be stored from the input device, or data should come from the input device, or data can be out to the output device. That means there is a communication, there should be some communication between the CPU, memory and the IO devices. Clear? Because why the communication required? Because the data transfer takes place between the CPU and the different IO devices. Okay. Now the problem with the IO devices and the CPU is the synchronization of the IO device with the CPU is a difficult task. Why? Because you know that CPU is the speed of the CPU is the highest in a computer system, and IO device is obviously very slow. Why it is very slow? Because IO device is actually related with the human interaction. We are not so fast like the CPU. Clear? So there is a speed gap between the CPU and IO. Okay, that means the characteristics of the IO is different from the processor in terms of the speed, and there may be some another issues also, all other issues also, but the main important thing is the speed. Speed of the CPU is much more than that of the IO device. Okay, so to make the IO device compatible, interface is necessary. Okay, why interface is necessary? The interface is required to bridge the speed gap between the CPU and the IO device. Clear? So there should be some communication technique between the IO device and the CPU of a machine. Okay. Now for the large computers, separate IO processor is used. That processor is different from the CPU, central processing unit. What is the function of the separate IO processor? Separate IO processor acts as a processor not for all the system, but only for the IO devices. Okay, that means it can generate the control signal for the IO devices if there is a separate IO processor. But that is for the large computers. And for the small computers, there should be some IO interface. Okay, IO drive. We should install some IO drive. So IO interface should be there, such that using that interface, CPU can communicate with the IO devices. Okay. So input output and the communication of the IO device with the processor is the today's topic. Clear? How IO device communicate with the CPU or communicate with the memory in the system. Clear? Now there are three ways to transfer the data between the computer and the physical IO device. Clear? All the machines uses one of the three techniques for transferring the data from CPU to the IO device or IO device to CPU. Okay. So what are the three techniques? The three techniques are called: number one, programmed IO; number two, interrupt IO. IO means the IO device here. And number three is the DMA or direct memory access. Okay. Today in this class, we will discuss only about the programmed IO. Next class, we will discuss about the interrupt IO. Now, what is programmed IO? From the name, you can easily guess that here one program is related with the transfer of the data from IO device to CPU and from CPU to IO device. That means the first point here it is written, the computer executes a program to communicate with the IO device via a register. That register is a special type of register that is called the IO port. Clear? So what is IO port? IO port is nothing but a register. The register is reserved for a particular IO device. Clear? That means computer executes a program means here some set of the instruction is required to write a data or a set of data into the IO device and to read a set of data from IO device. That means using the set of the instruction, computer can communicate with the IO device. So this is called a programmed IO, because one program is related with the IO exchange of the data between the IO device and the CPU. One program is related. Clear? And you know that as the program is related with the IO device, that means CPU has to execute the program. As you already know, any program is executed by the CPU in a RAM or random access memory. Here also CPU have to execute a set of the program to communicate with the IO device. Clear? That means to transfer the data from the memory to the IO port and IO port to the memory. Why port? Because port is a register. One register identifies one IO device. Clear? That means if there are 3 IO devices, there is a chance that there will be 3 IO ports. Clear? Each IO port is connected with one single device. Clear? Now, here IO operation executed under the direct control of the CPU. As I have already told that here one set of the instruction is executed to read the data from the IO device and to write the data into the IO device. So obviously, as one program is involved there, CPU executes the program. That means here the IO operation is done under the direct control of the CPU or the central processing unit. Clear? Now here always remember the transfer from IO device to memory cannot be done directly. It should be through CPU. Why? Because register is within the CPU. IO port is a register. That means if IO device want to transfer the data into the memory, it should go to the port. Okay, it cannot directly transfer the data from IO to memory. Similarly, if memory wants to output the data into the IO device, it should do using the CPU. Without bypassing CPU, memory cannot transfer the data to the IO device. Similarly, IO device cannot transfer the data to the memory bypassing the CPU. That means CPU is involved in the programmed IO. So what is programmed IO? In the programmed IO, a set of the program is executed to transfer the data from and to the IO device, and this program is executed under the direct control of the CPU. That means CPU controls the whole operation of the program IO. Clear? Now, how CPU execute the program for the IO device? So CPU carries out the operation only when the IO device is ready. Clear? That means CPU execute the programs only when it is ready. That means CPU time to time has to check the status of the IO device. Okay, that means suppose first at 10 seconds starting of the CPU, it will check the status of the IO device. Clear? To check whether the status bit is 1. Status bit is 1. The status means a special type of register. Status bit is 1 means IO is ready for transferring the data. Clear? So CPU will now execute the program. That means the read operation or write operation or in or out, that I will discuss later, for transferring the data from IO to CPU and CPU to IO. That means what is the thing here? The main thing is that CPU has to check the status of the IO device to find out whether the IO device is ready to transfer the data or whether the IO device is ready to take the data or receive the data. Clear? So CPU is programmed here it is written. That means CPU is programmed to check the status of the IO device before the starting of the transfer operation. Clear? Now, what are the steps? Steps performed by the CPU for transferring the data in the programmed IO to the IO device or from the IO device. Clear? First, suppose CPU is doing some work. After some time, there is a time gap. After some time, it will check, or after some period, it will check the status of the IO device. Clear? If it checks, finds that the status is set, that means device is ready to begin transfer, then it will go for the transfer operation. That means that it will execute the set of the program for transferring. Clear? Now, if it finds out that the device is not ready, it will again go to the step 1 and read the status of the IO device. So what is the advantage? Advantage here one program is written, and using that program, CPU can control the IO device. Now, what is the problem? Problem is, you can see from this tree that when it is not ready, again CPU has to go and read the status of the IO device. Now the thing is, it is not possible for CPU to read the status continuously for the IO device. Then CPU cannot do any other work. So after some time, after some period, suppose 3 seconds, 4 seconds, 5 seconds, this period CPU read the status to check whether the IO is ready or not. If it is ready, okay, it will transfer the data. It is not ready, it will again go for checking. So here, suppose CPU check at the 10 seconds. Okay, each 10 seconds CPU checks the status. So at first CPU is checking, then goes for the next 10 seconds. After 10 seconds, it will again checking the status of the IO. Now the problem is, suppose if 4th second or 5th second IO device required to transfer the data, what will happen? It cannot transfer because CPU has not checked the status of the IO device. So this is the problem. It has to wait until the 10th second comes. This is the problem. Again, another problem is that suppose CPU, suppose some program you have written that requires some IO operation. That means that requires some data, or that has to read, that has to memory out some output. That is the output some data into the output device. Clear? In this case also, suppose then CPU requires the IO device, then CPU goes to the checking for the status of the IO device. Suppose IO device is not ready. So CPU has to wait. When it will be ready, then it can only transfer the data. In this case, CPU remains idle. That means CPU is a high-speed device. IO device is a slow-speed device. Slow-speed device. CPU has to wait for the IO device for completion of its operation. So this whole process, that program IO, is something time-consuming. Though it is very flexible because one program is used for generating the status, for checking the status of the IO, and then CPU again execute some program to read the IO port or write from the IO port. Clear? Again, I repeat that CPU has to check the status, and then again it has to execute some instruction to read the IO port or to write into the IO port. Clear? So this is the steps performed by the CPU in programmed IO. I have already told there are 3 types of IO transfer operation. One is programmed IO, another is interrupt IO, another last one is the DMA. Here we are talking about the programmed IO. Clear? Now, as I have already told, CPU will execute a set of the instruction to read the IO port or write into the IO port. Now, as you already know, that when writing on instruction, you require some address. There are 2 types of address. One is the address for the instruction and address for the operand. That means in this case the IO port. Clear? Why? Because it requires the address of the register. Otherwise, it cannot store the data or cannot read the data from the for that particular device. So it requires the address of the particular device, which is actually the IO port. Clear? That means to write some instruction and to execute some instruction, CPU requires the address of the IO device in terms of the port. Clear? Now, there are 2 types of addressing mode for the IO read and write operation. That means the IO transfer operation with the CPU in programmed IO. In programmed IO, this is very necessary, or the requirement is very high for the address, because here you are writing one program and you are writing one instruction. You require the address of the port. That means the address of the register which is connected to the particular IO device. Clear? So there are 2 types of mapping for IO devices are used for programmed IO. Generally 2 types. One is called the memory mapped IO, first one, and second one is called the IO mapped IO. Clear? Now we will discuss what is memory mapped IO and what is IO mapped IO. Both are the address for the IO devices. Okay, both are the mapping of the address of the IO devices. Now see here, what is memory mapped IO. In the memory mapped IO, a part of the main memory address is assigned for the IO devices. You know that to execute a program, we require the main memory. And a part of the main memory is stored for the operating system, you already know. And a part of the memory is stored for the instruction and data, that is the stored program concept. Here also in the memory mapped IO, a part of the main memory address is also assigned for the IO device. That means if you write or read anything from that particular memory location, that means you are reading the particular IO port or writing into the particular IO port. That means that particular memory location is directly connected with the IO devices or IO ports. That means, what is the meaning of that? That means the usual load and store instruction, which is written in the point 2, can be used for transferring the data from and to the IO device. Again, I repeat, if I use the memory mapped IO, some portion of the memory, main memory, is used for addressing the IO devices. That means that portion is only reserved for the IO devices, and that is directly connected with the IO port of the system. If processor writes anything at that particular address which is reserved for the IO devices, that means it is writing to the particular IO device. If it reads something from that memory location which is reserved for the IO devices, that means it is reading the data from the particular IO devices which is connected with a particular location. Clear? Now the problem is how to distinguish between the memory and IO. In some device, the most significant bit is used to distinguish between the memory and IO address, because you are using the same RAM. So you have to distinguish which part is for the memory operation and which part for the IO operation. Here you have to make the reservation for the IO part. Clear? So here most significant bit is used to distinguish between the memory and IO. By looking to the most significant bits, processor will know whether this address is for the IO or whether this address for the memory operation. Clear? So here memory mapped IO, the same memory is used for storing the instruction or same general memory operations and for the IO operations. Clear? If MSB is 1 in some system, IO port is selected, otherwise memory is selected. That means if in the address bit MSB is most significant bit is 1, processor will understand that here it has to select the IO port connected with that particular address. If MSB is 0, most significant bit is 0, that means processor will understand that here the memory address is for general memory transfer operation, not for the IO devices. Clear? Now see, these are the two special type of instruction: load, store. You already know that load and store operation is used for loading some data into the accumulator and storing the data from accumulator to the particular device or register. Okay. So here LDA PA accumulator, that means here the data is transferred from the port address to the accumulator. The data which is stored into the particular port address. What is the port? Port means the particular register for a IO device. So LDA PA accumulator, that means the data will be transferred from the port address to the accumulator. Okay. And store is just the reverse, where data will be transferred from the accumulator. You know the accumulator is a special purpose register, special type of register. And here port address is the another register. Port is the another register which is for the IO devices. Data will be transferred from accumulator to the port. That means if this instruction executes by CPU, data will be transferred from the IO device to accumulator. Clear? Because IO device is connected with the particular port address. Similarly, if this instruction is executed, store, data will be transferred from the accumulator to the particular IO device. Clear? So using the simple operation which is used in the instruction, no separate instruction is required for the IO device. See here. Here the same instruction, here this instruction we also used for the memory operation. Suppose accumulator A ACC, that means data will be transferred from the register A to the accumulator. Similarly, store A accumulator, data will be transferred from the accumulator to the register A only. That means A is here is a simple register, not as the port address. So using the same instruction, we can access the memory. That means the suppose LDA A. So A is the register. This is used only for the memory operation purpose. Similarly, LDA PA, that means port address. That means the same instruction we are using for accessing the address of the memory and for accessing the port address of the memory. Okay. So no separate instruction is required for the memory mapped IO. Clear? Separate instruction means separate instruction for the IO device. The instruction which we will use for accessing the memory, we will use for accessing the IO device also. This is the advantage of using memory mapped IO. Clear? Generally, Motorola uses the memory mapped IO. Different types of manufacturer uses different types of mapping. Motorola uses the memory mapped IO. Clear? Now the architecture of the memory mapped IO will be clear from this figure. See here the thing is the here main memory and CPU. They are connected with a bus. They are the bus, data bus, and address bus. Okay. There are the two different control signal, read signal and write signal. And these are the IO devices. See, IO devices connected with the port A, port 1, port 2. This is the register, and this is the port 3. Okay, that means the data will be transferred from port A to the CPU register, from CPU register to main memory. Again, from main memory to the CPU register to the port. In this way, data will be transferred. See, one thing you notice here, that here the read and write operation, they are the same read and write operation CPU required for the main memory. See, read and write, these two signals are used in the main memory also, and these two signals also used in the IO port also. Okay, for memory mapped IO, because CPU requires the same instruction. I have already told same instruction for reading the IO ports and reading the memory. There is no change of the instruction. So they require the same control line read and write. This read and write, when activate for the main memory, CPU will access the data from the main memory. This read and write, when activate for the IO port, CPU will read the data from the IO port. Now the question is, how it's possible? Using the same read and load, that means the load and store operation, how it's possible to access the main memory and IO port? See, one example, it will be clear. Suppose the main memory address varies from 0 to 64. That means there are 6-bit address, so it varies from 0 to 64. Clear? Now, here suppose IO is reserved for 0 to 16 and memory is reserved for 17 to 64. Again, I repeat, total memory is 0 to 16, not 64, it should be 63. So 0 to 64, 63. IO varies from 0 to 16. Memory location varies from 17 to 63. What is the meaning of that? Meaning of that is, if the load and store operation access the memory location from 0 to 16, people will understand that this is the IO operation, IO transfer operation. And if load and store operation access the memory location from 17 to 64, people will understand that this is a IO simple memory operation. Clear? Now see the example. LDA 10 accumulator. That means CPU is instructed to load the accumulator from address 10 to data will be transferred from the address 10 to accumulator. Now what is the address 10? Address 10 is from 0 to 16. It is within 0 to 16. That means obviously processor will understand that this is actually a port number. See here 10 is connected with a port. Address number 10 is connected with a port. Clear? Similarly, store 12 accumulator. 12 accumulator means here data will be transferred from accumulator to address 12. Now what is address 12? CPU will check. It will check that 0 to 16 is reserved for the port. That means obviously this store operation, accumulator will store the data into the particular IO device which is connected with the port 12. So what is the port 12? See here, this is the port 12 and this is the IO port 3 and this is connected with the device B. Previous one connected with the previous A. So using the instruction, that means using the memory, processor will understand whether it is the IO transaction operation, IO transfer operation, or memory transfer operation. Similarly, suppose the same instruction LDA 10 accumulator. Sorry, I have written here wrong. We must correct. It should be, suppose LDA, it is wrong here. LDA, suppose 19 accumulator. That means the address is now 19. So as address is 19, it will check this is the simple memory operation 70 to 64. So CPU will understand this is a memory operation. Suppose again the store operation, store, suppose 25 accumulator, not 12, 25. So 25 lies between 17 and 64. So CPU will understand that this is again a memory operation, not a IO device operation, because the IO device address is reserved only for 0 to 16 addresses, not from 17 to 64. That means if the address is more than 17, obviously it will be a memory transfer operation, not the IO transfer operation. So this is called the memory mapped IO. Clear? That means when this instruction will be executed, this load and store, this read and write signal for IO port will be activated, not for the memory port. Okay. Similarly, when this instruction will be executed, this read and write operation for the main memory will be activated, not for the IO port operation. Clear? So this is called the memory mapped IO. Now, there is another technique that is called the IO mapped IO or isolated IO. Clear? The IO mapped IO, the memory and IO address spaces separate. The same memory, the same main memory is not shared between the IO and the memory devices. Okay. So obviously CPU executes separate instruction for memory and IO devices, because the same instruction it used, it will not understand whether it is in the memory or the IO devices. Clear? Now the thing is, here IO device and memory location can have the same address bit pattern. What is the meaning of that? In the previous case, we have seen that some memory is reserved for the IO operation and some memory is reserved for the memory operation. But in this case, there is no reservation for the IO. We have to use the different type of instruction for IO and different types of instruction for the memory. That means different types of instruction for the IO transfer operation and different types of instruction for the memory transfer operation. Clear? But here the memory may be same, because the memory, they are using the two different types of memory. So same memory bit pattern can be used for both IO and for the memory. That means suppose 00000001 bit, this may be the memory address, this may be the IO port address. So CPU, how CPU can differentiate between them? Using the different instruction, because CPU have the different instruction for the IO and different instruction for the memory. It will be clear from here. Now Intel 8086 processor, that means the Intel and all its family, actually uses the programmed IO, that means the IO mapped programmed IO. Okay, what is IO map? Here, see here, two operations are used, that is the in X and out X. In X means transfer the data from the port X to accumulator, and out X means transfer the data from the accumulator to port X. See here, here also instruction is executed, but this instruction is different from load and store instruction. Previously, the same load and store instruction we are used for the memory operation and IO operation. And here, for IO operation, we cannot use the load and store instruction. We have to use the separate instruction, which is exclusive for the IO operation, not for the memory operation. That instruction is in and out. When processor encounters these two instructions, in and out, and they decode the opcode, that means processor has to take the data from the IO device, and or processor has to store the data, that means out the data to the IO device, not the memory device. So in the previous case, in the memory mapped IO, processor differentiate between the IO and the memory depending on the address, and here processor differentiate between the memory and IO depending on the instruction, type of the instruction. Clear? In the previous case, there may be same instruction for IO operation, but address should be different. In this case, instruction is different, but address bit pattern may be same. Clear? Because there will be no conflict, because they are using the two different memory location for that. There is no reservation of the main memory for the IO device. Clear? So Intel 8086 microprocessor series use the IO mapped IO. So it will be clear from here. See here the architecture of the IO mapped IO. In this case, read and write signal is used, but see here, CPU use the for main memory read M and write M, two different signals, and for the IO port read IO, write IO, two different types of signal. Clear? In the previous case, see here, same read and write instruction is used, signal is used for the IO port and memory. So this is a common line. But here in the IO mapped IO architecture, see, different control line was used. Read M for reading the memory, write M for writing the memory, read IO for reading the IO, write IO for writing the IO. This is IO mapped IO. This is not memory mapped IO. Clear? So see here, two instructions I have written. Load 20 accumulator. That means data will be transferred from the accumulator to 20. Similarly, store, that means 11 accumulator. That means data from the accumulator to 11 at the port address, at the address 11 will be stored. This is a memory operation. Why? Because load and store, this is the memory instruction. In the set of the instruction, if you decode the opcode, this is a memory instruction. This is not a IO operation. Now see, in 20, out 30. So I have already told in 20 means data will be transferred from the 20 to the accumulator, out 20 means from the accumulator to the 30. Here 20 and 13, this is the port address. This 20 and this 20 is different. Clear? Though they have the same bit pattern, you know, 20 means the same bit pattern, but this 20 means this is in the one memory device where the memory operations are stored, and this is for the another memory device. This address is for the another memory device. How processor will differentiate? Processor will differentiate depending on the instruction. This is LDS STA, this is the memory instruction. If processor encounters this instruction, that means this is the memory operation. And if processor encounters this operation, that is the IO operation. So this is called the IO mapped IO. Clear? So we learned about two different types of mapping here. One is the memory mapped IO and another is the IO mapped IO. So limitation for what? Limitation for the programmed IO. So what we learned, that IO device can communicate with the CPU with the help of the programmed IO, where a set of the program is set of the instruction. Here you have learned either store, load store, or in out. Set of the instruction have to execute the CPU. CPU has to check the status of the IO, whether it is ready or not. If it is not ready, CPU has to wait. Or when IO is ready, it may be possible that CPU is busy with doing some another task. So that is there is a speed gap between the IO device and CPU for test and service. So this is the limitation of this programmed IO. And CPU has to spend time for testing and servicing IO devices. Suppose there is a large number of IO devices in the system, CPU has to check the status of each of the devices. So that is a time-consuming job. So this type of programmed IO is a slow process. So these are the limitation of the programmed IO. Next day we learn about the interrupt IO, which is faster than the programmed IO. Okay. So that's all for today. So thank you.